Hi everyone. Next we are moving to the superposition theorem. So look at the statement. In any network of a linear resistance containing more than one generator or a source of EMF. Just look at here circuit. More than one generator or EMF. See here 6 volt, right? Here 12 volt. More than one voltage source EMF. The current flows at any point in current flows at any point. For example, current flow here I1, current flow here I2, current flow here I3. Current flowing through any point. Okay. Point is a sum of all the currents which would flow at that time, at that point, if each generator were considered separately and all generators replaced for the time being by the resistance equivalent their internal resistances. Okay, just look at the diagram. I will explain the theorem properly. According to the statement of superposition theorem, if here more than one voltage source or current sources, any sources are present, the response of each source, remaining sources are deactivated. For example, in this circuit, the response of one source, that is a 6 voltage source, replaced by 0.5 internal resistance. Here, one source replaced by your 1 ohm internal resistance, the response what you got in the first case, that is the first case response, as well as in the second case, your second source is acting alone. You are taking the response of in the second case. The summation of the responses of each case, is equal to total current. That is the response of that particular current. For example, I1 is sum of I1 prime plus I1 double prime. Minus I1 double prime. Because of based on the current directions, you can choose. This is a forward direction, right? This is the opposite direction. So both are opposite to each other. That way the total current will be I1 dash minus I1 double dash. Finally, according to the superposition theorem, each source is acting alone. The response is sum of the each individual sources responses is equivalent to the actual current all sources are present if all sources are connected to the circuit. Okay, that's what superposition theorem. I hope everyone is clear about that. Now with help of this example, I will explain superposition theorem. Okay, right. So coming to here, according to the theorem, what is step 1? Each source is acting alone, remaining all other sources are replaced by the internal resistances. So here 6 voltage source acting alone, right? Acting alone, right. 12 ohm replaced by 12 volt replaced by internal resistance, that is a 1 ohm. If it is there is no internal resistance, simply it is short circuited. If there is no internal resistance, voltage is short circuited, current source is open circuited. If there is no internal resistance, keep it in mind. Okay, fine. Now I am going to calculate the responses of each branch. If 6 voltage source is present, I want current I1 prime. I1 prime is equal to V, that is 6 divided by total combination of all the resistances, equivalent resistance I need to calculate, that is the R equivalent. First of all, I need to calculate the R equivalent. It is very simple. See here, this 2 ohm and this 1 ohm connected in series, that may be equivalent to 2 plus 1 is equal to 3 ohms, right? This total entire combination parallel with 6 ohm. So R equivalent to 2 is equal to 6 into 3 by 6 plus 3. That may be equivalent to 2 ohm, right? Fine. After that, all this combination is equivalent to 2 ohm. That is series with 2.5 plus 0.5. So finally R equivalent is equal to 0.5 plus 2.5 plus 2 is equivalent to 5 ohms. Okay. So 6 divided by 5. It is 6 divided by 5, that may be equivalent to 1.2 amperes. So I got 1.2 amperes is a current I1 prime. So the first branch current is done. What about the remaining currents? So remaining currents I2 prime. If I know this current is 1.2 amperes, apply the current division rule, find out the currents. If I want I2 prime, opposite resistance is 6 ohm divided by total resistance 2 plus 1 plus 6, that is 9, into total current. What is the total current? 1.2. Okay, this is a 1 time, this is a 2 times, sorry, 3. This is a 2 times, this is a 3 times. 1 time 0.4 times, it is equal to 0.8 amperes. Is it okay? So I got this current value is equal to 0.8 amperes. Next, at the third current I prime, here mention I prime, right? I prime is equal to total current, again apply the current division rule, total current into, you want to find out this current, right? Opposite is this combination, that is a 3 divided by total is a 3 plus 6, 9. So this is a 1, this is a 3 times, this is a 1, this is a 0.4 times, that is equal to 0.4 amperes. So I got 0.4 amperes is a I prime. So I got all 3 currents, right? All 3 currents are I1 prime, next I2 prime, I prime. These are the 3 currents we have. Then we are moving to the second case, that is step 2. In the step 2, 12 voltage source acting alone. What about 6 voltage source replaced by 0.5 ohms. Okay. Now just do the calculations here. I want to find out I2 prime first, I2 double prime, that may be equivalent to V divided by R equivalent. Similarly in the previous case, I want to find out the R equivalent. So I want to find out the R equivalent. See here, these two combinations series. So R equivalent is equal to 2.5 plus 0.5, that may be equivalent to 3 ohms. The 3 ohms series with parallel with 6 ohm, right? 3 into 6 by 3 plus 6, that will be equivalent to 2 ohm. So this total entire combination is 2 ohm. After 2 ohm, R equivalent, therefore R equivalent is equal to 2 plus this 2 plus this 1, okay, internal resistance 1, that may be equivalent to 5 ohms. So here 12 divided by 5, that may be equivalent to 2.4 amperes. So once I got the current value 2.4 amperes, I can find out remaining currents. What are the remaining currents? I1 double prime, that is equal to total current into opposite resistance 6 divided by total resistance 3 plus 6, 9. This is 2 times, 3 times, here 1 time, here 0.8, that may be equivalent to 1.6 amperes. I got I1 prime also. So I2 double prime, here I1 double prime I got. So at the last I need to calculate this I double prime. So I double prime is equal to, again, total current into, okay, I double prime total current into opposite resistance is 3, total resistance is 9, 1 divided by 3, 1 time 0.8 it is a 0.8 amperes. So I got I double prime is a 0.8 amperes. So I got all three cases, right? Once I got all three cases, then I find out in the total responses, summation of according to theorem, summation of individual response is equal to total response. So I need to copy the circuit, right, in the step 3. Right. So here step 3. In the step 3, both the sources are present. Okay, both the sources are present. What will happen here? So here the current I1, the current I1 is equal to the response of first I1 prime minus in the second case opposite to that. Just look at here. Second case the current will be opposite. See here, this is the opposite one. That's why minus, subtraction. I1 double prime. What about the current I1 prime 1.2, I1 double prime that is at 2.4, right? I1 double prime 1.6, I am sorry, 1.6. That may be equivalent to minus 0.4 amperes. That means current direction is opposite to that our assumed direction. Change in current direction. Okay, minus 0.4. So that value is a minus 0.4 amperes. Next one, current I2. So I2 is equal to I2 prime minus I2 double prime. So what is I2 value? I2 prime value 0.8 minus here I2 double prime. Okay, here original direction, this is the original direction. That means actual I2 double prime minus I2 prime. Why I am taking I2 double prime first? Because in the problem itself it is mentioned original current direction is same as I2 double prime. That's why I am taking the I2 double prime reference here. Why I am consider I1 prime minus I1 double prime? Because here original direction is same as I1 prime. That's why I am taking first I1 prime. Just small logic here. That's what we are not charging current. That means battery going to be charged in this case. Here I2 double prime is equal to 2.4 minus 0.8. That may be equivalent to 1.6 amperes. Last I is equal to I prime plus I double prime. Okay, so both the directions are same. So I prime is a 0.4, I double prime is a 0.8. That may be equivalent to 1.2 amperes. 1.2 amperes. This is about the solution for this problem. For your understanding purpose, I am explaining clearly total entire superposition theorem with the help of this example. So I hope that you are enjoy the class. So similarly, I am started the new course, that is a work experience teacher KVS TGT. Those both electronics as well as electrical students, BTech students are eligible to write those exams. So if you are interested, you can go to the notification in the website, just apply that particular examination and then go to our mobile app and see the course. I will explain complete syllabus related to the KVS TGT work experience teacher. Thank you. Next we are moving to the example 1.4. Using superposition theorem, calculate the current in each branch of a network shown in the figure. So you are preparing for KVS exam, right? So in KVS exam is an objective exam. They won't ask you find current, calculate the each branch. They are asking about current flowing through the BDR 4 ohm resistance otherwise any one resistance they are asking. But the first you learn the concept, that's why I will calculate all the currents. Just listen. Okay, so superposition theorem, according to the statement, each source acting alone, remaining all other sources are replaced by the short circuit in case of voltage source, open circuit in case of current source, if sources are ideal condition. That is a statement. So in this case, I am going to short circuit 6 volt. That means 12 volt source acting alone. For your understanding purpose, I am writing each and every step, but in the examination you do directly. 12 voltage source acting alone. Okay, so when I was 12 voltage source acting alone, what about the circuit? This is a 6 ohm, this is a 12 volt, as well as 4 ohms, and this one is a short circuited 4 ohms. So you want to calculate the current. In the case 1, I1 prime, this is a first case. This current maybe note down that I2 prime and I3 prime. I want all these currents. Look at here. So you want I1 dash, find out the total resistance. What about the total resistance? These two are connected in parallel, both are 4 and 4 ohms, that will be equivalent to 2. Okay, you want to find out the R equivalent. Plus this is a 6 ohms. After calculating this parallel connection, you will get this 2 ohms series with the 6 ohm. Directly I am writing 8 ohms. Once you got the total resistance 8 ohms, total this combination, I want to find out the current I1 dash. I1 dash is equal to V, that is a 12 divided by 8. So 12 divided by 8 is a current. That will be equivalent to 1.5 amperes. Okay, once you got this current is 1.5 amperes, I1 dash, this particular branch current is done. Coming to I2 dash and I3 dash, everyone listen carefully. I2 dash and I3 dash. So you need not to be calculate current division rule, nothing, just common sense you can use. This is a 1.5 amperes. That means these two resistances are same. Two resistors are same, current will be divided equally, right? That means 1.5 divided equally means 0.75. Here also 0.75. All of you got my point. So the step 1 is done. Why am I explaining these shortcuts? Because you are writing the objective examination. That's why I'm explaining. Otherwise I am applying the current division rule, opposite resistance by total resistance into total current. You can also do that, but the object examination time is very, very important. Next, step 2. In the step 2, 12 voltage source is short circuited. That means 6 voltage source acting alone. So whenever 6 voltage source acting alone, short circuit this 12 voltage source, right? This is the resistance 6 ohm, this is the resistance 4 ohm, this is the resistance 4 ohm, and voltage source is present, that is a 6 volt. Okay, this is a equivalent circuit. Now see here, this current I2 double prime, this current I1 double prime, this current I3 double prime. How I may know? Because this plus sign, the current will be delivering from this side, the current will be divided to two types. because there is no voltage source in this case. Now I'm going to calculate I2 dash first, I2 double dash. How to calculate the I2 double dash? First I'm going to calculate the total resistance, then 6 divided by R equivalent. I want to calculate the R equivalent first. How to calculate the R equivalent? See here, these two are connected in what? Parallel. Whenever 6 and 4 connected in parallel, you will get 2.4. 6 into 4 divided by 6 plus 4. The total resistance parallel series with 4 ohms. Okay. Then R equivalent is equal to 6 and 4 parallel, that is a 2.4 plus 4, that will be 6.4 ohms. You got 6 divided by 6.4, that may be equivalent to 0.94 amperes. Okay, so you got the current I2 dash. Next we are going to calculate I1 dash, I1 double dash, as well as I3 double dash. So look at here, you know this current is 0.94. This is 4 ohm, this is 6 ohm. Both the resistances are different, that's why I apply the current division rule. That is a 0 total current into, you want to find out the current here, right? Opposite resistance 4 divided by 6 plus 4, 10. That may be equivalent to 0.38 amperes. Okay. Next, you want to find out the current in the 6 ohm 4 ohm resistance, 0.4, 6 divided by 10. That may be equivalent to 0.56. Finally, I got all the currents, right? I want total currents. So total currents I1, I2 and I3. So if you want look at here, I am going to copy the circuit here. Right. So by look at the circuit in the step 3, this is the final result. Step 3. So both the sources are present. Okay. Whenever both the sources are present, I1, you want I1. In the first case, this is the current direction. In the second case, this is the correction. The first case I1 prime, second case I1 double prime. Both are opposite. That's why whenever both are opposite, total current will be, in the first case 1.5, in the second case 0.38. That may be equivalent to 1.12 amperes. Is coming to I2. This is the I2, this is the direction I2, that is the I2 prime. Again this is the direction I2 prime, I2 double prime. That will be equivalent to 0.94 minus 0.75. That will be equivalent to 0.19 ampere. Okay. Next, here I3 prime plus I3 double prime. Both are same direction. So that may be equivalent to this is a value 1.31 amperes. Okay, this is about the solution. Okay, next we are moving to the example 4.2. So here the circuit shown in the figure, this is a circuit, is excited by the two voltage sources of 0 terminal resistances. So see here, this is a 20 ohms and this 13 ohms. Those internal resistances are 0. That means ideal voltage sources. Use superposition principle to find the current flowing through common resistance R3. What is the common resistance R3? This is the common resistance R3 and voltage drop across it. Okay, you want to find out the both the current and as well as voltage. Let us do that. So you know superposition theorem, the step 1 here, 20 voltage source acting alone. So whenever 20 voltage source acting alone, our equivalent circuit diagram will be voltage source, 4 ohm resistance. This is short circuited, that means grounded. Okay. So here in the case I will make you, this is the current I1 prime. You want current only through 4 ohm resistance, 12 ohm resistance here. You want current here, that may be I3, I3 prime. This is a I2 prime. I don't want to calculate all the currents. I want to calculate this current only. Current flowing through the 12 ohms as well as current voltage across the 12 ohms. So simple. See here. I want the current here, right? That's why first I am going to find out the current I1. These two are connected in parallel, 4 and 12. So R equivalent 1, for example, 4 into 12 by 4 plus 12, that is equal to 48 divided by 16, that may be equivalent to 3 ohms. Now this 3 ohms series with this 4, because these two combination I got 3. So finally R equivalent you got 4 plus 3, that may be equivalent to 7 ohms. Okay, clear up to here? So once you got total resistance is 7 ohms, then I can find I1 prime is equal, that is a total current, V divided by 7. So this is a 2 times 2.14, 6 is there, 60. So approximately 2.85 amperes. I got here 2.85 amperes. I want this current flowing through the 12 ohm resistance. Then apply current division rule. I3 prime is equal to total current is 2.85 into opposite resistance 4 divided by total resistance is 60. Okay. So approximately I got 0.7125 amperes. This is the first case. Then we are moving to the step 2. Okay, next 36 voltage source acting alone. Whenever 36 voltage source acting alone, again these currents are I1 double prime. You want this current, right? That will be I3 double prime. Now, so first of all I want to find out the total current. Then only it is possible to find out this current flowing through the 12 ohm resistance. So for that, 4 and 12 connected in parallel, already we calculated previously, R equivalent you got 3 ohms, right? Again this 3 ohms series with 4 ohm, okay, that may be equivalent to 3 plus 4, 7 ohms. Still no, we did already here 4 and 12, that is a 3 ohm, 3 plus 4, 7 ohm. Okay, till now it is completed. Next, current. Here make the difference. I1 double prime is equal to V, that is 36 by 7. That may be equivalent to 5.142 amperes approximately. You want this current, right? So I3 double prime is equal to total current into opposite resistance 4 divided by total resistance 4 plus 6. So current will be 1.285. Finally, final result, I3 current flowing through the 12 ohm resistance, that is I1 I3 prime plus, that is a 0.7125 0.7125 plus 1.2855. This is the total current. So you got total current, first part is done. Voltage across 12 ohms, that is equal to current into resistance V is equal to IR, Ohm's law. Resistance, current is 1.99 amperes, resistance is 12 ohm, that may be 23.976 volt. Okay, this is about the solution.